Hello guys, my name is Amay and I'm doing this course on Udemy for GoLang, and the instructor Todd McLeod has asked us to create a video of teaching a topic from the functions module of this course. So it's an exciting exercise to do. I have always wanted to create a video content, but I'd never really had the courage, but this is a great push from Todd. So to do this, I have selected an exercise from his functions module, which is exercise number 5. So let's go ahead and read this. What does it say? So the first 2 points are about creating types of with the name square and circle, and we have to attach a method to this type that calculates the area of these shapes. So you have the formula for circle, which is pi r square, and the square is a length into its width, or simply side squared. Next, you have to create a type shape that defines an interface as anything that has the area method. Further ahead, we have to create a function info, which takes the type shape and then prints the area. Finally, create values of type square and circle and use the function info to print the area of square and circle. All right, so let's go to GoLang playground and try to implement this exercise. All right. So the first two bullets talk about creating types square and circle. So we'll use the type struct for that. So we create a square type struct, and the square will have a property side, and I'll give it a type of float32. All right. Next step, we have to create a circle. So type circle struct, and we'll give it a property radius, which is a float 32 as well. All right, we're done with the first two bullets. Moving ahead, we have to create a method, attach a method to each that recalculates area and returns it. Sorry. So going ahead, we have to create a method, right? So what is a method? A method is a function which is attached to a type. So we create a function area. This is an empty function area which takes nothing, which returns nothing, which is attached to nothing. Now to attach the function to the type square first, we'll give it a receiver of type square and assign it a variable s. Now this is supposed to return the area of the square, which is your s dot side multiplied by s dot side. And this is going to return a float32. So I'll mention the return type over here, float32. Moving ahead, let's do the same for a circle. We'll attach it to the type circle by giving it a receiver. The name will be the same, area. The return type is also going to be the same, float32. And this is going to return the area of circle, which is pi r square, right? Now to get the value of pi, we'll use the math package and import it in the program, and we'll use math.pi to get the value of pi, and then multiply it by r square, that is the radius square, which is c dot radius multiplied by c dot radius. Right, that's done. We are done with the methods. The next step is to create a type shape that defines an interface as anything that has the area method. So we have to create an interface with the name shape that defines an interface as anything that has the area method. All right, going ahead. So we create a type shape, type interface, and attach it to the function area. So this is going to be implemented by any type which has the method area. Now I made this mistake before of not mentioning the return type of the function in this declaration. So we have to mention the return type float32 so that the compiler can correctly find the function that we are referring to. So we are referring to the function area, which returns a float32. So that's what it means. All right, moving forward, we are done with shape. Now we have to create a function info, which takes the type shape and then prints the area. So step by step, create a function info that takes the type shape, and it has to print something. It has to print the area of the function that has been passed to it. So we will print the function area by calling area on the shape that has been passed to it. All right, I think that's enough for us. All right, so this is done. As the next step, we have to create the value square and circle in the main function, and then use the function info to print individually the area of the circle that we have declared and the square. Alrighty. So let's go ahead and create a square. So square can be declared by using the short declaration operator and then mentioning the identifier of the type square, and then assigning the property side a value, and always don't forget to end it with a comma. All right. Then we create a circle, the value circle, which will have a radius, and let's give it a radius of 5. Okay. Post this, we have to call info on each of the shapes, and this is supposed to print the area of the shapes. So let's go ahead and run this program. Okay, that ran without an error. That's great. So the area of the square that we have passed is 16, and area of the circle, that is pi r square, is 78.53982. Right. So let's look at this program and understand how it works. So first we declare a square, which is struct, and it has a property side. So it has been given a value of 4. Next we declare a circle of type circle, which is a struct and has a property radius, and we have assigned it a value of 5. Now when we call info on square, the compiler will look for info, and we'll see that info is taking a parameter of type shape, but we are passing it a type square. So how does it manage that? But it also sees that shape is an interface, and it's tied to the method to the function area. So any function or any struct that has the function area attached to it will implement the shape interface. So what we can see over here is, to put it in plain language, square, the type square is also a shape. The type circle is also a shape. So we can pass square and circle even though info is asking for a shape. Now when we are trying to print it by calling shape area on the shape object that we have passed, that is the first object square, it will look for the relevant method that will be used to calculate this. So since this is a type square, the compiler is going to go to the definition of the area function, which is tied to the square type, and use this to calculate the value of SHP, the variable SHP dot area, and that's how this area of square will run. And the same goes for a circle. So I hope this was clear, and I thank Todd for giving me this opportunity giving me this push to make this video. He's a great instructor, and I would highly recommend this course. Thank you very much.